Okay, I rethought my position. So in this demonstration video, what I want to do is I want to show you how to indirectly manipulate the decision process that goes into selecting the root port. Now, just to clarify, we see here that Ethernet 1.2 is the root port. And the reason being is I changed the value to a number lower than the other interface that's being used. Now, what I'm going to do is I'm going to make it 4 again. So I'm going to say configure interface E12. And what I'm going to do is I'm going to up arrow and I'm going to say Control A, and I'm going to say no spanning tree cost 0. And that should allow everything to revert back to the way it was. So if I say show spanning tree for VLAN 100, what we should see now is 1.1 is the root port. So it's changed back to the way it was supposed to be. Now we still know that 0002, which is in 9K2, is the root bridge still. So didn't modify that. Now, if we look here, we have the matching cost. Now, I mentioned the fact that the priority would be 128 by default. But what you need to understand is that priority is the priority that's being advertised to me from the root bridge. This value right here is what is locally set. So as an example, if I were to come in here and make the priority here on Ethernet 1.2 the lowest possible value possible for the priority, that would make sure or should ensure that the higher port number, so port 1, got picked because 1 is less than 2. But as I said, the port priority is going to allow me to be able to pick who I want to be in charge as far as who is going to be elected as the root port. However, this is an indirect manipulation. So if I come over here and make a change on 9K1, what we're going to find is that this is not going to change the election. I will demonstrate by doing that. I'll say Ethernet 1.2, and I'm going to say spanning tree port priority, and I'm going to give it a numeric value as low as possible. I'm going to pick 0, knowing full well that the lowest value is what is going to determine who is going to be elected the root port. However, when I execute the show spanning tree VLAN 100, what we're going to see here is even though the priority is 0, the interface Ethernet 1.1 is still the root port. So this value locally means nothing. What I need to do is I need to go to the root bridge or to the upstream device, and what I need to do is I need to have it advertise to me what the value is. Now let's look at this. So first of all, what I want to do is I'm going to remove that configuration. So I'm going to go back into Ethernet 1.2, and I'm going to come in here and say no spanning tree port priority 0. Let's see if that corrected the issue. So if I say show spanning tree for VLAN 100, now we see it's 128 across the board, and we see that the root port was elected because the number of 1 is less than 2. So we're right back to where we were. But I want to know what's being advertised by 9K2 to me. So the way I do that is I say show spanning tree for VLAN 1, and I'm going to execute the detailed keyword, and the interfaces that I want to look at are going to be Ethernet 1.1 and Ethernet 1.2. Okay, so there they are. So there's Ethernet 1.1. It has a port number of 1, and we see Ethernet 1.2 has a port number of 2. We see that Ethernet 1.1 for VLAN 100 is the root port, and we see that port 2, Ethernet 1.2 for VLAN 100 is blocking. Now it's called an alternate port, and we'll get into that when we talk about spanning tree a little bit more. It's called an alternate port because if I lose the root port, it will immediately take over. And that's because we support a process called rapid spanning tree, but we'll talk about that when we get to spanning tree. What I want to pay attention to here is I want to look at the designated port ID. Notice this is the value of 128.1. Now this isn't the local value, this is the designated port. Anytime you see a designated value in this output, that means it's the information that's being advertised by the adjacent switch. So when we look at this, I have my values here where I have my port priority. This is my local priority. This is my local cost. And the designated values that I have is I have my designated bridge priority that we have set up here is 100. And if we take a look at the idea of the port ID, so the designated port ID is 128.1. So what I want to do is I want to make 1/2 the root port on 9K1 without making any modifications or changes to 9K1. All my changes must take place on 9K2. This is what is referred to as an indirect manipulation. So I'm going to go to 9K2 and I'm going to go to config T, interface Ethernet 1/2. And what I'm going to do is I'm going to say spanning tree port priority, and I'm going to go ahead and say 0. Now, we're going to see some interesting things that take place. So first and foremost, what I want to do is I'm going to say show spanning tree, and what you're going to see here is Ethernet 1.2 is now the root port. Now, looking at this, I can't tell why that decision took place. But if I repeat the detailed command and I take a look all the way down to the two interfaces that I'm concerned with, and start looking at the designated port ID, notice the designated port ID, that's the information that's being identified or advertised from 9K2 to me via Ethernet 1.1 is 128.1. However, when I look at the designated port ID that's being advertised from 9K2 Ethernet 1.2 to me, it has a port priority of 0. Therefore, the lower port priority will be the interface that is elected as the root port. Thus, taking Ethernet 1.1 and making it a blocking port, and it is now an alternate port because it's going to also be able to immediately take over in the event that the existing root port were to fail. So I just wanted to go through and clarify that and demonstrate you how you can make those verifications, showing you the difference between a cost manipulation, which is a direct manipulation, i.e. you're doing it on the device that you want to manipulate, and a port priority manipulation, which is an indirect manipulation, which needs to be done on the adjacent switch. So with that being said, I hope this has helped you guys understand a little bit more about how to manipulate the root port election, and we'll talk about more things involving spanning tree the moment we finish our theoretical conversations about spanning tree and how it prevents loops and some of the problems that it can actually insert into our topologies. So I'll see you guys in that video.